Now we go for our second day, and we have the pleasure and the honor to have this morning an opening keynote from Klaus Iglberger. Did I say it correctly?
So, yes.
Well, so my year in Germany was useful.
Yes, absolutely.
Good. So I'm pretty sure that many of you have read his book, C++ Software Design. If you have not done that, do it next week, the latest. I routinely say that this book is the best book I have read in the past 10 years.
Thank you.
It's not a compliment, it's just the truth. So I have been pushing Klaus for several years before we really made the matching in the agendas so he could be here. So thank you very much, Klaus, for being here. And he is going to talk us about the real problem of C++. Which amazes me is that you only see one problem. So thank you very much, Klaus, and go ahead, please.
All right, thank you. So, thank you for the nice introduction. So then, first of all, from my point of view, a wonderful good morning, and welcome to the first talk of the second day of this conference, which is just another word of saying, or another way of saying, thank you for being here at 9 a.m. I really appreciate this. So, you might know me as the person that talks a lot about software design. So in the past 3-4 years, I have primarily talked about software design in general, software design patterns. But today I decided to actually talk about something different. And that is simply because I think there is a more important problem to talk about right now. So let's do not stall. Let's talk about the elephant in the room. C++ does have a problem. A safety problem. And you might have heard from various sources that there is indeed a lot of pressure on C++. There is first of all the NSA, who claims that it might be not a good idea to use C++ anymore. Then there's the White House that pretty much says the same thing. The European Union, by the way, does exactly the same thing, arguing that we need to take more steps in the direction of cybersecurity. And of course, there's a lot of bad press about C/C++, which is another story. So, a lot of negativity. That, I believe, is a problem. So, you might ask, do we really have a problem, or is this just some bureaucrats that talk about this from top down? Well, this is indeed a question that you could ask, but I would say yes, we do have a problem if you still are trapped in the classic C++ mindset. But let's explore this a little later. Let's first ask a question, how did you get there? And that's actually a pretty simple thing to answer. For decades, pretty much from the very beginning, C++ has made choices towards performance. Performance. C++ is a performance-driven language. And so whenever there was a decision between should we do this a little more safely or faster, well, pretty much always, not always, but almost always, the decision was make it faster. But there's a reason behind this. And I think this was actually nicely expressed by John Culp in This is C++. You can always build on fast code something that is safer. And so to say it directly in John's words, this leads us to the observation that he can build safe on top of fast. But he can't build fast on top of safe. What this means is that given an API that does no domain or other testing, one can build an interface on top of that API that adds any necessary checking, making it safe. That sounds reasonable, absolutely. But now given this pressure from outside, was this a bad strategy? Does this actually mean that C++ is broken? So already at this point, I can clearly say absolutely no. Absolutely no. It is true that it's not a perfect language. We have to do some work. We'll talk about this also a little bit. But there's a way, way more important, yes, we have to continue to improve the language to make writing code simpler. It's not necessarily super simple today, but I believe there is a way more important task to do today. So we have to way better communicate how to write C++ today. And that is, I believe, where we fail. So to quote Herb Sutter, the immediate problem is that it's too easy by default to write security and safety vulnerabilities in C++ that would have been caught by strict enforcement of known rules for type, bounds, initialization, and lifetime language safety. So, known rules. Indeed, we have various rules, good rules, safe rules to write C++. And so, let's talk a little bit about these rules, the way we actually should use the language for these four, I would say, writers of the apocalypse. So let's talk about bound safety, type safety, initialization safety, and lifetime safety. And we'll even throw in one more. Undefined behavior. Now, of course, you say, Klaus, there's only 4 writers of the apocalypse. Now we have 5. That doesn't match up anymore. I disagree. There may be actually a 5th one already, which might be the worst today. But let's talk about these one by one. I'm actually just starting off with bound safety. So let's talk about an example. Let's say that we, first of all, have some country class, struct. So a country has a name, it has a capital, it has an area, and residents, a number of residents. Then we have a continent. So a continent has a name. This may be Europe, this may be Africa, whatever. And of course, it also has countries, a vector of countries. So now, here's the real thing. Now, we want to print the 5 biggest countries. So the first thing we get is some continents from somewhere. Continents containing countries. So now I have a vector of continents. Now, I first start with an empty vector of countries because the first thing I need to do is to extract those countries from the big vector. Now, at this point, I could now ask you, what does this code do? And yeah, frighteningly, some people after probably 5 to 10 seconds would give an answer, but most of you would probably just look at this for 30 seconds, perhaps a minute, until you then slowly start to figure out what this code actually does. And so, because we don't have a lot of time, we go through all the continents, we go through all the countries in the continent, and we actually do not just immediately put this into this vector of countries. No, we now do a search. We search the position where this country would fit. So we do a sort right away. We insert this country such that the largest country by area is first, and the smallest country is last. Okay. Some people now slowly nod, say, okay, this is what this does. Interesting. Okay, but now we have those countries in a big vector. Now I select the 5 biggest countries. Just the 5 biggest, right? And then there's another set of loops. Just dealing with those 5 biggest countries, because now I want them in a different order. Again, I could just ask you, what does this code do? And again, you would look at this for a couple of seconds, scratch your head a little bit, think, and slowly but still you might realize, okay, now I'm apparently ordering by the number of residents, and the country with the most residents is first now. So, and then we would print those 5 countries. Okay, that's what this code does. And yeah, this was much faster than it could have been. Yeah, you would have thought about these loops much, much longer. But now some of you might actually think, whoa, wait. There's a problem. We assume there are 5 countries in this vector. And of course, it's kind of safe to assume because worldwide we have approximately 200 countries. So yeah, probably it's a lot of countries. But what if this is not? What if my input just gives me 4 countries? Or 3? Definitely less than 5. And there's a couple of places in this code that definitely would not work well under this condition. So that is a problem. And just for the sake of reference, this is actually the UB smiley, or UB emoji, right? So whenever you see that, it's not a good thing. This is bad for so many reasons. It's so difficult to understand. And of course, because it's difficult to understand, it's also kind of difficult to write. Because it's difficult to write, it's kind of easy to introduce bugs. And here it is. Now, it was so difficult that you just did not think about, well, special site conditions. This is not good C++ anymore. No. Okay, we could use an assert, of course. But we can do better. Much better. So let's retry in this form. So here's the second version of print 5 biggest countries. In the first line, again, we get some continents containing countries. Okay, from somewhere. Could also be a parametered function, doesn't matter. But now I have this vector of continents, which I simply put into a transform. A pipe bit, I would say. Actually, it's not pipe operator, but it's a nice way to say this. So we pipe it into transform to select the countries. Now, this will not return a vector of countries. No, this returns a view on a couple of vectors that contain countries. It's not one vector yet. But we can do that by joining all these vectors together. And now we have a view that, well, pretends we have one big selection, one sequence of countries. Amazing. And this is just something that we now store in a vector. So now we have a vector of countries, which you can sort. So we now sort based on size, area, the area of the country. Now, we select the 5 biggest countries. So this is what take does. And then once I have the 5 biggest ones, and again, this is just the view, we sort these 5 and just these these 5 largest countries by population. And then we print them. That's the same code. But just so much better. So it's shorter. It easily fits on one slide. Now, before it was 1.5 to 2 slides. Now it's 1, and even less than 1. It's so much simpler. Yeah, I know. At this point, some of you will cry, no, Klaus, this is more complicated. I don't know what transform does, how it works. No, do not confuse simple with unfamiliar. You might not have used this a lot before. And so, yeah, you might not be entirely familiar with it yet, but if you would use it a little bit, you would so quickly fall into the pattern to use this everywhere because it is simpler. It's also faster, because we have replaced an insertion sort with a quick sort, or more specifically an intro sort. So this sort call here in the middle, this just makes it faster already. And there's no manual handling of indices iterators anywhere. And hence, there's absolutely no opportunity to introduce a bounce error. 0. And now, if you believe, oh, Klaus, still there's a take 5. Well, there's a 5 still. But it doesn't mean take exactly 5 anymore. As before, it says take it maximum 5. If it's 4, it takes 4. If it's 3, it takes 3. It's perfectly safe. So this is how C++ looks today. And this perfectly aligns with the philosophy of C++. Perfectly. Because what we're doing is we're building safe on top of fast. We didn't lose anything. We actually gained something. We gained simplicity, understandability, and even performance. But no, this is not a new thing. Absolutely not. So you might know this gentleman, at least I don't mean personally. I mean, you might have heard about John Parent, who in 2013 gave a very, very important talk called C++ Seasoning. And in his talks, he says the following thing. If you want to improve your code quality in your organization, I would say take all your coding guidelines and replace them with one goal. That's how important I think this one goal is. No raw loops. This will make the biggest change in code quality within your organization. And he meant that. And he was so correct about that. Pretty much in 2013, he already said there's no bounce errors in C++. But then, this is 2013 only. That's not when this started. No. This goes back to pretty much the beginning of C++. The STL algorithms were introduced in 1994. This is when this philosophy started. So this is not a new thing. This is old, indeed. And so, no, I don't think it's a language problem. But still, people, right? Now, many developers would complain, this is so complicated. Or, I would like to use it, but my colleagues won't understand my code anymore. Then, of course, the performance people. Well, this will probably reduce performance, right? And I will rather stick to what I've used the last 20 years. But then there's also one special kind of people, the people that say, yeah, of course I would use that. But I cannot use C++20 yet. So consequently, I cannot use C++ ranges. But no. Ranges have been around for so long also. So you should be aware of ranges v3, the original ranges implementation, which is not something that C++20 people can use. No, look here. It's available for C++14, 17, 20. Everybody can use this today, except for the people that still work in the Stone Age. That is unfortunate, but it is everybody can use this. And so, to say in the words of Gerald Weinberg, no matter what the problem is, it's always a people problem. So, let's talk about another issue. Let's talk about undefined behavior for a second. So again, I have a problem. I start with a piece of code. So let's say that we have a function called generate prices. Say this is some test driver for some stock market application. So you would pass a start price and you would pass a count. Count is the number of prices you want to generate. Then we would start off with a vector of count elements. And the first element is immediately set to the start price, because we want the start price to be in the beginning. The next, there is some logic, some lambda, whatever, that determines a new price. Now, something that, based on the given prices, computes a new price. And this is what we pass to std ranges generate. So we now generate a couple of prices in this vector. So then we return the prices. So then there is a test generate prices function. A test function. Everybody needs tests, right? So this function takes a start price too, it takes count, that's what we need to generate prices, but it also takes expected prices that we can compare to. Oops, this was too quick. So generate prices would be called, this would give us a result. We would create a vector of expected prices and would simply compare them. Good. So, and then we use this, for instance, in the main function. Somewhere we test generate prices. For instance, with 10, 0, this should not return any price. And with 10, 1, and then of course the starting price is 10. Great! It's amazing, right? Good code. Because first we test. Yeah, the code is testable, proves it's good code. And you've seen std ranges generate on top and std equal. So now we use algorithms. Yay! Okay, but a few of you spotted that this is not great code yet. Because, yes, of course, what happens if the count is 0? We access the 0th element, which is not here if we have count of 0. We also assume that we can go to the next element, which is, of course, undefined behavior. So now, of course, you not say, yeah, Klaus, we get it. We should use more algorithms, more range. But wait, here's another suggestion. So because, again, we can just do much better with very, very little effort. So let's put another keyword in front of generate prices. Let's put constexpr, which nowadays is easily possible. True, if you still work in C+11, it sucks. C+14 is a little better. 17, oh, this is where it really starts to be fun. 20 is great. 23 even better. So constexpr. The function, the test function, I could make this constexpr, or just because I can today, consteval. Why not? And now suddenly I have this tremendous opportunity to not just use asserts, but static assert. Suddenly it's a compile time test. And guess what happens? Guess what happens? It does not compile. It does not compile. Now you say, wait, that's bad. No, this is great. This is amazing. So look here. GCC 14.2 says error, dereferencing a null pointer. That's what it is. A std vector probably stores a couple of null pointers. You try to access it. That's undefined behavior. Clang, just the same. It's just a slightly different formulation of the error message. Assignment to dereference null pointer is not allowed in a constant expression. Boah, that's fantastic, isn't it? Really fantastic. But this is exactly how it should be. This is what the C++ standard demands of implementations. So if you look in the undefined behavior section, it explicitly says that evaluation of a constant expression never exhibits behavior specifically specified as undefined in, and pretty much these links are the entire C++ standard. So, by definition, there is no undefined behavior in anything that you compile at compile time. Run at compile time, sorry. But again, this is not something that is new. No, Jason Turner, for years, I would have almost said have decades, because it feels like it, has told us this is how we do things today. So pro tip from last year's NDC Takedown, make sure you test in both constexpr and non-constexpr contexts. This is how it's done today. And again, not new. This is not just 2024. He has said this for years. I think this is the first talk that I know of where you said this so clearly. Constexpr all the things. Not just because things run at compile time. No, because you can guarantee there is not a single bit of undefined behavior in your code. You know that for certain. So, there's other talks. I would like to reference to Hannah too. She's one who says, why not make constexpr everything? Everything should be constexpr. By default, then this kind of stuff cannot happen anymore. And that is today's attitude for sure. So, but now, of course, critics. Some people would say, well, this sounds great, sounds amazing, but Klaus, I cannot add constexpr in front of every function. So much of our functionality is not yet constexpr. And so the compiler would constantly complain, nothing would work anymore. It's really not an argument at all. It's you, it's your code. Because all you have to do is to write a proper structure, a proper design. You have to separate the things accordingly. And this is something that Brian Ruth in Thinking Functional in C++ has done really well. What he explains in very nice examples is that all you need to do is to separate actions, calculations, and data. And once you do that, the green stuff suddenly works splendidly, can be constexprified. And that's most of the code, the vast majority of your code base. Some things are not constexpr. In-out I/O, for instance, is not. But this is left out. And if you can do 98% of the code base, it's simple. But again, this is not new. This is something we've been doing for decades. Properly structuring code, separating concerns. This is an ages-old principle, paradigm. And so, again, no matter what the problem is, it's a people problem. Now, there's one more thing, of course, type safety. So again, I just start with a little example. So, I apologize up front, by the way. Please do not leave the room. Please do not fall off your seat. Please do not lose any hair. This is terrible. And still, you now have to look at this for a few minutes, a few seconds, hopefully only. So, we have an extrapolate position function. But then, it takes an x and a y as references, as double reference. That's the position. And then it takes a double t. It takes vx and vy, which is some kind of velocity, of course. And then optionally, you can pass an acceleration, ax and ay, which you can now use to extrapolate some position. If if this does not cause a cold shower running down your spine, if this does not make you lose hair, whoa, I do not want to see your code base. This is terrible. So it's so easy to swap values. This is an invitation to introduce errors everywhere. Yeah, why is the time the third parameter? Why? There's no logic behind this. And then it's 7 parameters. Perhaps you're proud that you can remember 7. Others cannot. 7 is already beyond 5, and 5 is proven to be something that is kind of a maximum for many. This is something that Matouche would agree with 100%. There's not a single unit. What is that? Meters? Seconds? Nobody knows. And returning the immutable reference? Just because it's 2 values? Seriously? This is not up-to-date C++. But it never was. This is just bad and always has been bad. This is terrible. And now, since the very beginning of C++, since C+98, we have utilized strong types to solve this problem. Types that strongly express what you mean. So now the function takes a position. Oh, now I have an idea what this is. And it makes sense in a 2D sense that it has 2 values, x and y, followed by time. And it's not just time, it's second. Now I know what this is. The velocity is a meter per second. Oh, again, I know exactly what this is. I know the units. I know how it can be combined with a second. And the acceleration may be a meter per square second. That's how things should look like today. And then I can also return a position. I can return 2 things easily. So today we utilize strong types everywhere. Ints, doubles, there's just not so much value to that. Now, do not take this for something that you should use productively right away, but it gives you a flavor of what you need, because it's not complicated. You just need a little type that wraps, well, say a double. Then you need a construct that hopefully is explicit. Without that keyword, it wouldn't make a lot of sense. That is 100% necessity here. And then, of course, constexpr. Why not? It's so trivial. And perhaps we can even sneak in a little notice card here. There's so many nice little features today that help us to avoid errors. That's one of them. And so now with this, you could easily create a second. And there would be no question anymore. What is that? It's a second. Yeah, the double suddenly has a strong meaning. It has semantics. This is good. But now, okay, again, you could say, wait. What if I pass an int? That would work, that would compile, because there's still these nasty little type conversions that happen in C++. Yeah, the built-in conversions, standard conversions, and they mess this up entirely, right? No, not at all. No, not at all. It's so simple to fix this. So look here. The constructor, the second constructor, is just extended by a little requires. So we make this a function template that takes anything but, at the same time, demands that it takes a double only. So if you now take an int, this would be a compilation error. So users only have to pass a double. There's no choice. It must be a double. And of course, you could do exactly the same with your assignment operator, or any operator where you want to avoid conversions. Now, you might feel like this is a little strict. It must be a double. Couldn't we just relax this a little? Well, of course, it's your choice. You are in control. You decide what kind of conversion you want to allow. So if you want narrowing conversions, avoid narrowing conversions, but allow anything else, great. Write the according concept. This is a one-line call or one-line thing. And then suddenly you avoid any narrowing conversion. You are in control. But just adding the single line of code. So now, the second criticism at this point is often, oh, now everything is a template. But now, again, please do not confuse the fact that this is a function that contains everything. There is interface, there is implementation. The interface can be a function template of this sort that checks conversions, prevents conversions. But implementation doesn't have to be. You can hide that, you can put this in the source file, It's just a simple check up front. So, but then, abstractions. Doesn't this just make the code slow? Isn't this the biggest problem why we don't use this? Okay, let's try this by using Compiler Explorer. So I've now one of these strong types. So some strong type for int in this case. So here int, let's call it second. And then I have a test function takes an int, and I have a test function takes a second. It does something, yeah, and returns the according type also. So what do you guess? Which function is faster? On the assembly level? Of course, I wouldn't show it if the strong type would be terrible. No, it's exactly, and 100% exactly the same code. And not just with O3. O2 is totally enough in this case. Compilers can look through this so easily. And compilers are so amazing nowadays, it's so simple for them to turn this into exactly the same code that you would have with just a built-in type. And so again, not a surprise. This is what we can do well. And this is what we've been doing since the beginning. We build safe on top of fast. So Guy Davidson called this the superpower of C++. So there's a talk given by him which just says, this is what what makes C++ really strong. Creating this kind of abstraction, creating this kind of extra semantic information. But then, no, I really have to write all this myself? No. Now, first of all, if you want a second, you would not use the second that I just showed. This was just a nice single class to demonstrate things. But you would use C++, the C++ standard library, of course. We have a second already, std chronos second. That's simple. That's already here and implemented in a very, very elegant and very clever way. But if you need something else, right now you might have to just wait a little more. So I could recommend Björn Faller's strong type library. That is a good one. And you can pretty much use this for any kind of strong type. You could also use Jonathan Müller's typesafe library. Also a good one. Just pick what you like a little better. Or perhaps if you really want to go to the best that we have today, you could also choose Armature-Spush MP units, which is so good. That's actually currently on the road for C++ 29, right? 29, not 26, yeah. So this is, from my perspective, probably the thing that you should start today. Because it's simple and because it's already available. And so not doing this, well, yeah, you might complain that it's now much more complicated. But no, I believe this simplifies things. It avoids errors. It's just better. So, to quote myself, some people prefer to search for program errors for a few days instead of spending a few seconds to add a helpful line of code. And so, from my perspective, it's a people problem. Now, let's talk about lifetime safety for a bit. This is something that I've talked about for years, because this is something that, from a software design perspective, easily just comes to mind. And so, yes, yeah, this is the one opportunity where I can show design patterns again. And as soon as I say design patterns, of course, just a flash of this book, this picture, the good old Gang of Four book. So, this book was written, or released at least in 1994, 30 years ago. And yes, this is the pattern that defines 23 of the most commonly used design patterns, which are still used today. Absolutely. I would argue there is no reasonable piece of code, sensible, large piece of code, which does not use these design patterns in some form. But now, let's pick one of these. Let's pick the visitor design pattern. This is the UML class diagram that you'd find in the code, or in the book. Now, if you don't know that, don't worry. Doesn't matter at all. But you do see that this pattern, well, of course, has this object-oriented flavor. Inheritance hierarchies. And yes, of course, this is how it was done in 1994, before the first C++ standard. This is just what it was, the time. But yes, this classic style of doing things has a lot of disadvantages. So first, you have these two inheritance hierarchies. And so consequently, of course, I have a lot of virtual function calls, 2 for every operations, 1 on the right, 1 on the left side. This slows things down. This is a performance penalty, for sure, and a big one because it's 2 virtual functions. Then this style of programming promotes dynamic memory allocation. It doesn't mean you don't have to, yeah, but it promotes that. And because it promotes that, you also suffer the performance loss due to many small manual memory allocations, which of course you would do with make unique and similar functions, but still, it's a memory allocation. And then what you would get from make unique is a pointer. So this would totally mean that you now have to manage a pointer, which of course you would do by means of unique pointer. But now you have pointers. And pointers, of course, slow things down again. Pointers are the natural enemy of the optimizer. What should it optimize when it's just a runtime address? And pointers can be null pointers. You have to check for null pointers. If you don't even use unique pointers, you might have dangling pointers. Performance, a big performance loss. But then, of course, there's also the danger of lifetime-related bugs. It always was there. Pointers and references. Now, there's an amazing talk given by Dave Abrams, who in 2022 talked about just that thing. So Dave was, for a long time, away from C++, worked at Apple, developed the Swift programming language, following his own belief that values are better. Now, he didn't quite succeed in Swift, so now he's back in C++, but spreading news again. And so in this talk, he starts pretty much with an amazing quote. People, we have a problem. And it's one we may not really like to face. In fact, we maybe can't even see it because we're swimming in it. It's like water to the fish. I'm talking about reference semantics. So he talks about pointers and references and argues that this is where so many program problems come from. So many bugs, so many performance issues also. But the solution is simple. The solution would be to use more values, value semantics. So let me just walk you through this visitor design pattern as we would do it today. So this is my go-to example. It's always the same, so many people have seen it before, but don't worry, you will survive it. So you might have a circle that we want to draw. So note, this is not a special circle. Note, there is no base class whatsoever. It's just a simple geometric primitive. And I don't have to use a pointer to circle. I use a circle value. Then, of course, there are other shapes, say squares, rectangles, etc. Just the same. Now, we need operations on such a thing. Say we want to draw them. That's it. Sure, the implementation is missing. I don't know which library we're using for that, but this is it. And again, I don't need any base class. I don't need any pointer to that. I need a value. That's it. So, and then I would potentially store this in a std variant. A variant that might contain a circle or a square, and then potentially other shapes as well. Again, this is not a pointer. This is a value. I have a shape value, an abstraction that still is just a value, not a pointer. So then we might draw all the shapes in a vector of shapes. This draw all shapes function so it takes values as input. Now I now go through values. No base pointers anywhere. And then finally, which is from my point of view the most beautiful place here, in the main function I just do not allocate anywhere. Yeah, there's no pointers, no allocations, only values, and I really create values. I put a circle in the vector. I put a square in the vector. And it always makes me happy to see that, because it's so simple. I always argue this is something that even your beloved ones at home could understand, assuming that they're not into programming. Show them this piece of code, and intuitively they would argue, oh, of course, there's a vector of shapes, we can put shapes inside. What's the problem? It's so simple. Again, this is how C++ looks today. So, no base classes anywhere. No virtual functions anywhere. No pointers in the entire example. And sure, I'm not talking about std vector inside. From our perspective, there is no pointer and no dynamic memory allocation. And again, vector internally may allocate, but we don't care. It's encapsulated, it's nicely managed inside, we don't have to worry. And it's simpler. And at the same time, it's faster. Way faster than what we've done back in the 90s, because there's no pointers anymore, no virtual function calls, no allocations. Of course, it's faster. So I've talked about this so many times. If this is interesting, I've given an entire talk about the visitor design pattern, but I've also talked a lot about alternatives, like the type erasure pattern. Now check this out if this is of interest to you. So, this truly is much better. It's simpler. It's even faster. Then why isn't everybody using this? Well, once again, no matter what the problem is, it's a people problem. So, okay, I think by now you kind of get it. The language might not be perfect. Oh, it definitely is not. There's so many quirks and curiosities. But we can still do some homework. We can still improve. And this is exactly what we're currently doing. This is what the C++ Standardization Committee is trying. But there's so many good solutions already. So no, it's not a language problem. So, no, programming in C++ is not safe by default. It would be great if it would be, but okay. That's where we have to do some homework. But the solutions that we have are amazing. I would argue most boundary issues, perhaps not all of them, but most of them are just eliminated entirely by not using indices and iterators. So by primarily using algorithms, ranges, and the like. I would argue 99% of type safety problems are just simply resolved by means of using strong types and some constraints where you control the conversions. And actually I say 99% because if I would say 100 and then you do have a type safety issue, then it would come to me and complain. So 99 is safe for me. It could be more. Almost all lifetime safety issues, and again, I'm just guessing, approximately 99% can be resolved by just using values instead of pointers and references. And there's absolutely no undefined behavior anymore today if you just consequently use constexpr and do the according testing. Now, constexpr alone is unfortunately not enough. You have to test the function accordingly. So, and this is not new solutions. They've been around for a long time. And this is what C++ always has been. So the real problem, from my perspective, is not the language. It absolutely isn't. It's a mindset problem. It's a problem that people are still working in the old ways. And apparently still love that. But then complain about the language. No, it is a people problem. It is a people problem for sure. So, some people just don't know. They just don't know indeed. So we still have, in this entire community, way too many people that still write what I would call classic C++. That still use for loops, that still use ints and doubles in interfaces, that easily allows switching things. And they don't know about our best practices, the guidelines. They've never heard about the core guidelines before. And there's still way too many people that still don't use the tools, which from today's perspective are just an integral part of a good piece of code. It should be an integral part of every C++ project. And yes, I'm not just talking about a little testing tool. No, of course, you know there's so much more. There's testing tools, fuzzers. Yeah, this is not a weird thing anymore. This is something that everybody should use. We have sanitizers, of course, static code analysis. There is so much out there nowadays, so much good stuff, that there's just no excuse not using this anymore. So, but now. So now I see, of course, a couple of bewildered people. Angry stares, potentially. Well, Klaus, wait. Did you just say that we don't know what we're doing? That we are not using the tools properly? No, I didn't say that. But that's a problem with a conference talk. It really is. Because I believe we're in a bubble. This is what I would call the 10% bubble. So we here at the conference, we are the people that do know. We are the people that do care. Absolutely. This is why we're here. We want to learn. We want to get better. And so we learn about these things. We use these things, try them out, and we write better code. but it's few people. So just give you a little proof. Go to any C++, say CPPCon video. Go to Bjarne's keynotes. This is the thing that everybody should see. Every year, CPPCon, you watch Bjarne's keynote. And not just because he's the inventor, because he usually has good messages. So look at the number of people that watched the keynotes in the last couple of years. So you might see something like say 20,000. You might think, whoa, 20,000 people. That's a lot. But no, that's a drop. We have millions of C++ developers in the world. Millions. And 20,000 of them watch these talks. That's pathetic. And so, this was a nice way. I think we are actually in an even smaller bubble. I think it's more like a 1% bubble. And 99% of the community don't appear on conferences, don't read books, don't learn about the new ways. We do. So, consider yourself to be part of this little bubble. So, okay. Now you might argue, Klaus, wait. Isn't this now a very strong argument to start a new programming language? A language that does everything good right from the start. Then we wouldn't have this problem anymore, right? If you do believe this, you might not have really understood the problem. So, do you truly believe that these 99% of people, if they now would have to use another programming language, would write good code? Do you truly believe that? Do you think that the people suddenly care about the philosophy and the culture of the language? No, absolutely not. They would just write horrible code in any other language too, because they just want to get the job done. That's it. So there is just a small amount of people that truly cares. That seems to be the problem. So some people just prefer to learn a new language for several years instead of spending a few weeks to probably learn their own programming language. Ignorance is bliss, right? But okay, then there's people that don't know, but still speak up. Oh, and that is the worst. That, from my perspective, truly is the worst. So I actually decided not to show any specific examples. Then people might have complained afterwards. But I can at least tell you that there have been interviews of people that claim that C++ is, it's not a modern language anymore because you have to use so many pointers. Apparently this person didn't know the language at all. It might have known the language 20 years ago, but not the modern C++ you use today. We don't use so many pointers anymore. There are no pointer-related problems in modern C++ anymore. So then, there have been talks of people that claim there is no solution, and the C++ standardization committee doesn't do anything about it. They are ignorant. Well, apparently this again was somebody who just doesn't know the language, that did not really invest a little time into learning the culture of the language. So for the people that now watch this video that feel addressed, please just shut up. Go home and leave us alone. And then, of course, there's some people that would like to know. Some people that would like to learn, how does it work? And for that purpose, we have teaching material, right? Books. And, of course, also online courses and other material. That's going to solve the problem. This is the people that can do the right thing, right? I wish that would be right. But did you actually read any of the books that were updated, say, for C+23? Perhaps not, because you might know that already. But if you now give one of these books that teach C+23, old books to people, they still, in chapter 5, learn about pointer arithmetic. Oh my God! One of the first things that people believe you have to do in C++ is pointer arithmetic. This is devastating. This is wrong. If we continue this way to teach people C++, of course things will not improve. Of course not. And so, do me a favor. If you read any of these books, or get something, see something from the book, perhaps you don't read it in total, because I wouldn't too, just give it a very bad review. This actually helps, because a big problem is often not the authors. Some of the authors would like to do the update, but they cannot. They are not given the time by their publishers. Time to market, we have to be fast. It's a money problem, and so again, it's a people problem. So leave a bad review, a really bad review. Make it clear this is totally unacceptable from today's perspective. Make them suffer. And I mean this. So to just give one example that I personally felt good, really good, learn C++ by example from Francis Buontempo. So it's not a beginner's book. It's a book that teaches people that have been using C++ a long time ago and that are now back into C++ and want to learn how things work today. Good approach, because there are a lot of those people. But in this book, you will not find the old ways of doing things. It's the new ways. I think this was a good approach. Sure, it might not be perfect. You might still find a raw loop somewhere. But I think this is one step towards the right thing. So check this out. This might be useful. So it's a people problem. It really is. So now, of course, you're asking, what can we do? Is there anything we can do except for trying to deprecate everything old and doing something else? So, well, I try to do my own part. So as a trainer consultant, I try to teach people how C++ is used today. And so I kind of believe, I hope that I'm actually changing things for the better. So perhaps this helps. Yeah, perhaps a couple of hundred people every year get a little more input on that, and perhaps they spread the news a little bit. But it's not enough. Yeah, even if people like Matush and I share this knowledge, it's not enough. And so we need you. We need you. If you know one of these people, yeah, your colleagues, your coworkers, the people that do not really care, spread the word that working in classic C++ is pretty much like groveling in dirt. We don't do this. We don't like this. And dirty programmers are not good programmers. So tell them to stand up, to clean themselves up, to be proud to use the modern language, to use what we have today, the best practices, the tools, and then perhaps, eventually, this will make a difference. So, with our best practices and tools, I believe we can easily remove the vast majority of safety issues. The vast majority. Hopefully you get the point, it's way beyond 90%. And then, to last but not least, quote Herb Sutter again, if there were 90 to 98% fewer C++ types, bounds, initialization, or lifetime vulnerabilities, we wouldn't be having this discussion. Thank you very much.
Great talk. Thank you very much. I think I completely agree. So, questions? Wow.
Some questions.
No, I have to disagree with the talk, actually, a lot. Namely, the point is, you said it quite often, it's a people problem and not a language problem. And so the stuff you showed solves the language problem, in my view, not the people's problem. Namely, two examples. So we have private and public access specifiers in C++. Mm-hmm. They don't serve any purpose except to restrict the language so that people do not do stupid stuff. Or another example, why is Rust safer? Because people are forced to write memory safe code, so they are forced to. And you also asked the question, would people write better code if they would use another language? And the answer is yes, if they would be forced to. So if they can't write bad code, then the code is better. And so I think the only possible way to make C++ safer is to force people to do it.
That's exactly what C++ is currently trying in the form of profiles. But, well, you're totally allowed to disagree. But you might not be teaching. You might not see the world out there. You might not meet the people that are in the 99% group. That's, I believe, that gives you a different perspective. You cannot force them in that way. They would still not use that.
But I think you also don't see the people in the 95% group, probably. And these are the bigger problem, I guess.
Okay, that I didn't get, but okay, let's
No, I
get the
mean,
next
usually
question.
much more people than me, but
Yes.
not every C++ developer takes C++ courses, and here's
Exactly, that's my point.
Yeah.
So please try not to enter in a one-to-one discussion because there will be more people wanting to ask maybe your question, and you give me back the microphone immediately.
Yeah. How do you take a code base that has been there 20 years and say to a company that you have to update that to make it more secure when the company wants to make money? No, take the code and modify it.
Which is part of the problem, right? I would not argue that you have to change everything right away. That causes problems. When you change code, you introduce new bugs, new vulnerabilities potentially, leave it. But if you now start to embrace this mindset, if you start to write good code from today on, and also do the refactorings accordingly, slowly but steadily, better code spreads over the entire code base. Other people see that, other people pick this up, and as a habit do the same thing. And so you're starting to automatically write and create better code. And that's something that works fantastically. You just have to start somewhere. Yeah? Don't change, write new code. Yes?
Yeah. What do you tell library writers like myself who target C++11 because there are still more than a third of programmers out there using C++11?
Unfortunately, which is really a part of the problem. I would say use the best thing that you can. Set a good example. Also in C++11 you can use strong types. You have enable if, which is not as elegant, not as efficient as a C+20 concept, but can do pretty much the same. Yeah, so in a way, you have the same options with some limitations. Sorry.
Regarding type safety, strong typing, actually, what do you draw the line? Should we strong type every parameter of every function we use? Because it's kind of tedious to...
The tedious argument, yeah, so much more complicated. Well, what is simpler? To use one of these libraries to write a line of code to define such a strong type, and that's all it takes. Or to later find the bug where you have accidentally swapped some arguments because it wasn't clear in which order they're expected. I think this one line is simpler. Yeah, it saves you time. Of course, not every single thing has additional semantics. Perhaps sometimes an int is just an int. But most of the time, I believe, there is additional information. This is what you can pass by means of a strong type.
How do I persuade someone to do things correctly if they only want to make the code work?
It's a people problem, right? No, seriously. You cannot force somebody to change the mind, and some people just don't care. Well, once it works, however it is done, it is done. Difficult question. I don't really have an answer. If I would have, by the way, I might be rich. So.
Yeah. By the way, I saw the list of books that you were recommending, and I felt that most of them were not for newcomers.
Sure.
Yeah. So we also need to make good recommendations about how do we teach the very basic stuff. Yeah. Today, my favorite, and I am happy to be educated or more of them, might be probably third edition of Programming Principles and Practice from Viernes, which, by the way, is smaller than previous versions, and that's great.
Yeah, so it's a follow-up question about the strong types. Mm-hmm. You have just said that sometimes an int is just an int. If you have a function with two ints, how do you know which one comes faster? Is there a way, or is there some thinking about name parameters in C++? Or
just for constructors. Designated initializers might give you a little bit of that, but it's just constructors right now, so primarily for structs. Yeah, so it's not something that you can use everywhere.
I have mixed feelings about that thing. In the moment that you allow to have named parameters, you are promoting functions with many, many parameters, and that's wrong. My recommendation is even stricter than you, 4 parameters as a maximum. That is in my static analysis, maximum, ever. If a student gives me a function with more than 4 parameters, they get a 0, period.
For it.
And no 2 consecutive parameters of the same type, period.
Period.
2 ints consecutive, you get a 0.
José Daniel, don't enter in one-to-one discussions. Don't enter in one-to-one discussions, José Daniel. Thank you for the talk. It's a great talk.
So, it's a little too noisy now?
Thank you for the talk. It was a great talk, and I learned a lot. But my question is from a corporate perspective, because I work in a very or more or less big department, and we are all C++ developers and other language developers, and I concur with the other person that said that a lot of people doesn't care, but I want to enforce from the corporate point of view to enforce some policies to make them care, or at least make them disallow make bad code. What, in your opinion, are the first policies or the policies I have to enforce right now, right today, to make better code and make people care?
So there's something actually simple. This is something simple you can do: static code analysis. Yeah, many of the bad things today, many of the core guidelines are already checked. And if you make this mandatory, if this is even built into the IDE, checking code while they write, that might force people to write better code already. It's of course not a silver bullet. It's usually the small things. Static code analysis is pretty limited in what it can do, but it might be a start. Then what I usually recommend is raise awareness. If there is a truly big problem, do not just put one developer on it, that developer solves it, and everybody that rest of the people never see that. Make everybody aware, create a meeting, say here, this was a huge problem, it cost us a lot of money, can we do better? And if you, as soon as you involve people in the process of writing better code, perhaps some more people will care. Start to realize, okay, perhaps we can do better. So raise awareness also. I think this actually costs less than the bugs. A little meeting to raise awareness is not that expensive. Okay.
It's amazing that you mentioned it, because that was literally what I wanted to say. So,
okay.
And you know me enough that I'm always this weird guy who doesn't really want doesn't really write C++ code anymore, right? Only PPTs. But my question is that I see this as a raise awareness problem. So my question is, do you think we can do better in popularizing this, especially with the younger generation, to learn this way the C++? And also, when are you starting your TikTok?
But perhaps this is the way. We try to do something. Some people do try. I'm not on TikTok, but I'm on LinkedIn, and there are a couple of people that pretty much on a daily basis show how things C++ can look today, how it should work today. Perhaps this is a start. Perhaps some people are more affinitive to or attracted by TikTok. Perhaps this is the people that can then address the TikTok community. I think this helps. If you take a look at politics, apparently there is an impact. Perhaps there is an impact for developers as well. We could try.
Okay, thank you. We are going to cut here to be on schedule. So thank you very much, Klaus. I really enjoyed.